Hello, this is Dynamic FA. Today I'm going to commission a single conveyor system with the two sensors. Let's look at the configuration first. Mechanically, we have one conveyor and with the DC motor with two sensors. One is the reverse stop, the other one is forward stop. We have 4 buttons: auto, manual, forward, reverse. Auto, if you press the auto button, then conveyor will stop for starting forward until it hit the reverse sensor. Once it hit the reverse sensor, then it will go back, starting to go back. Once it hit the reverse stop, then once it hit the forward stop, then it will start moving to backward, and then it will hit the reverse stop, and then it will go forever. It was moving forward and backward. And also we have manual button. Manual button, you can turn the system into the manual mode. And in the manual mode, if you press the forward button, then the machine start forward until it hit the forward stop sensor. Same thing, if you press reverse sensor, it start moving. But this one is only momentary. If you release the button, then motor will stop. Okay. And additionally, I just want to show you a quick diagram so you can understand what actually include in this system. I have power supply 240 to 24 volt, and another 2 power supply. I have 5 volt DC power supply. This one is for the sensors and buttons for the input, because I have only 5 volt devices here, so I use the relay, 5 volt relay, to deliver the 24 volt to the PLC. Okay, and another power supply. This is for the output, 1.6 volt DC. This one for the conveyor motor, because if I give 5 volt, the motor turns too fast. So I just use the 1.6 regulated voltage and then deliver to the relay, and then relay drive the motor. This is the electrical configuration. Now let's look at the actual configuration. Okay, I'll turn the cam on. Okay, this is the MicroLogix1400 and input relay, and this is 1.6 volt. That's the DC motor regulator, DC motor power supply, and then the one above, that's little power supply, that's for the 5 volt. And we have a conveyor system, and then we have buttons, and we have 2 relay for the output of DC motor, and we have a 24 volt power supply. Okay, this is the thing we have for the single conveyor system. Okay, then I will start programming. Okay, this is the PLC. I already connected PLC, but let me connect online. Okay, go online. I don't need to save it. Create new file. Okay. This is the actual program inside the PLC. There's nothing, nothing. So we're going to make from scratch. Okay, let's assign input first. Okay, input the input 0/0 is reverse stop. This is the symbol, but symbol have to be unique. But command description, it can be any infrared sensor 1, and this is a reverse DC motor. The motor reverse stop. Sorry, stop. Okay. Let's see. Okay, copy. 0/1 is forward stop. Forward stop. As you can see, it accepts only capital, not lowercase. This is same. Just press paste, and this is the number 2. My represents 2. This one forward. Okay, that's good. And we have buttons from number 4. Buttons, auto mode. Button. Button switch. Button switch for auto mode. Button switch for auto mode. Number 5, manual. Button manual mode. Button. Manual mode. Button. Button. Switch. Okay, that's this is forward. Forward. Yeah. Forward button. Forward DC motor. Forward button. Okay, and the last one is reverse button. Reverse button and reverse button. Reverse button switch. Okay. DC motor. Okay. Now we have done for input. The input, we have to test it. Okay, let's I'm going to turn the input 0/0 is on. Okay, now it's on. Oh, not yet. No, not oh. Okay. Sorry. It has a bad contact, so I just fixed it. Okay, input 0 is on, and this is a reverse stop. And I'm going to activate the forward stop sensor now. It's on, and it's off. Okay, it's working good. And 4 buttons. So I'm going to press the auto mode button switch. Working good. And now manual mode button. Okay, good. Forward, on, that's good. Okay, working good. So we have finished adding command and symbol for the input. Now I'm going to do output. Output. Output 0/0 is forward. DC motor forward. Okay, DC motor forward would be better. DC motor forward. DC motor forward. Right. Okay. And DC motor reverse. DC motor reverse. Run. Okay, I need to add this one relay. Run relay. That'll be better. Okay, reverse relay. Run relay. Okay, now I have done the adding command and symbol. Okay, then now what you can do, simply we need to commission the motor safely. So normally what I do, I make a simple program so I can commission it. I'm going to delete everything later, but I just want to do test quickly. So okay, this one here, insert long. I'm going to add the button forward here, forward button to forward. Sorry, forward. I can't find it. Anyway, that's the number is output 0/0. Okay, and accept. Test. The reason I make a simple programming for this to check the direction of the motor. Sometimes direction of the motor could be different. So okay, now I'm going to test it. I will turn the camera on. Okay, this is the forward button. Okay, I'll press. Okay, the direction is correct because the forward direction is that way. This is the forward stop. So this one, when I press this button, it turns forward. Okay, the direction is correct. We have finished the I/O test. Now we can programming. Okay, now before we start programming, we need to turn the remote off, go offline, because simple change you can do online change, but I just want to save it. Conveyor. Okay. Here we need to make a structure, programming structure. So we have only one subroutine, but I want to have more. Firstly, control. We can have auto mode. Description. This is for the auto control mode. Auto mode control. Okay, and I want to have one more. Manual mode. This is subroutine. Manual mode control. And we need to have input and output. Yeah. Input for the input assignment. Okay, and same as input, we have output. This is subroutine for output assignment. Yep. Okay. We have 4 routine. Now we start assigning. Okay, this is we made 4 routines, and we're going to do input first. Input, we can assign it. Normally I assign input memory to another like a B memory or something like that. So because the reason why I do that, you make the programming, and then later if you want to change it, then, or if you want to copy that to another project, then if you use actual input, then you can't copy. So you need to do too much things. But if you have everything in this B memory, binary memory, then you can keep that, and then you just change the input subroutine, then you can make the system same. So here what I do, yeah, I can add here back to users, and then you can add append run, insert run, and we can add input reverse stop. Okay, and timer. We need timer for filtering. And what we need is we need one more bridge here. We connect, and then another bridge here. Okay, and then timer. Sorry, not timer, not off on delay timer, but I need a off delay timer. That's good. And I need the binary memory. So I'm going to add coil. Okay. Click here, coil. Okay, coil. Okay, D3, and this one I'm going to use this one as a filtered input reverse stop. Filtered reverse stop, infrared sensor 1, filtered input. Okay, now we can set it up on delay timer T4 0. This one is input timer reverse stop on timer, reverse stop. This is on delay timer for reverse stop sensor. Okay, I'm going to use 0.01 second timer, and I'm probably 10. I'm sorry, 10. 10 means 0.01 second multiply 10. That means 0.1 second. Time of delay will be the same. I'm going to use different register, but before 1, and this will be also the same. This one off delay timer for forward for sorry, reverse stop infrared sensor. Same off timer reverse stop reverse stop. Same thing, 0.01 seconds, and I want to use 10. Okay, that's good. And then we can test it. Accept run edit and test to edit, yes, and assemble it, yes. But we can see input here, turn it on, but the timer not working because this is the subroutine LADA 5 input, but this one is not connected to main program. So what we can do, we call main program and insert run and add. If you go a bit further to the right hand side, then you can see compare, move, shift, program, control. You can see JSR, click JSR, drop it into the run. Then you can see subroutine file number. Subroutine file number is this number here. This is the subroutine file number. You can now input is number 5. Input number 5. And this one call routine. Input subroutine. Routine. I don't want symbol. I just call. Okay, and if we download it, sorry, this one. If you accept long edit and test edit, yes, and assemble it, yes. Then jump to subroutine function. Every time, every scan, and PLC look at the main program subroutine, then it start every cycle, repeat every time. It calls jump to subroutine. That means call that input and then execute that routine. So that means now this routine is actually working. So if you see here, then you can see this is output of time delay. So this is output of time delay, and this is output of delay timer. So this bit turned off a little bit later than this actual signal, and then this output is actually turned on a little bit later than this input. So I want to have this input call user, and oh sorry, I want to edit, online edit, and then I can add here. I'm going to add here. This one is on delay timer, so this one this one is okay, this one is would be T4. On delay timer is number 0 dot dm. Enter, then okay, and this one will be activated after 0.1 second of reverse stop sensor on. And then also I need to have a off delay filtered. So when you want to off delay filtered, then it has to be stay off until this on. Okay, and then once this on, we want on T4 yeah, sorry, I think this is not a good idea. Off delay timer. Okay, this is I think this have to be here. This would be better. And then we use this one. T4 that T4 T4 1.dm, and enter. Then okay, 1 second. This one maybe I'll try something else. T4 dot 1.dm. Okay, this is the signal. This one, once this signal is on, then it has time delay, and time delay started, and after 0.1 second and off delay time start, not time off delay, but off delay timer is on until this signal is on. Once this signal is off, then it will drop, but it will keep 0.1 second longer. So I can increase this number 1 second, and we will clearly see what it happened in the logic. Okay, then now I need to change this one to the 1 second, so I can test it. I can show you clearly what does timer mean. Assemble, edit. Okay, yes, yeah, this one. Okay, let's try. I need to change this one to 1 second. Enter, and then this one to 1 second. I'm sorry, this hasn't been changed. 1 second. That means 100. That means this one is 10 seconds. Enter. 10 second time delay, on time delay, 10 second off time delay. Sure. Okay, then we will see how does it work. Enter. Okay, I'm gonna test it, and yes, enter. And oh, this is assembly. Edit. Okay. Yes. Okay, then I can show you
long
working. So once it gets on, but on delay is not on yet until it gets 10. That means 10 seconds. After 10 seconds, we got everything on, and then this signal on.
I think
but
to stop it,
even I remove this, remove my hand. This signal is off. Still, this signal stay on until this timer off. Still off. Still on.
Okay.
This bit still on.
Upload
Until 10 seconds after 10 seconds of the signal off. Okay, now it's off. That means this is filtered by this signal is filtered by 2 timers. Okay, this is the download. This is the sample, like a one for the filtering one input. Here, back to wrong mode. And now, I don't need a 10 seconds time delay, so I just change the time base back to 0.01 second, and this one to 0.01 second. Okay, now we can see actual timer. I don't need such a long timer, long filtered timer. Okay, test edit and assemble edit. Yes, then now it's 0.01 multiply 10. That means 0.1 second. This one is also 0.1 second. We can see 0.1 second on time delay, off time delay too. It's looks almost same, but it actually has time delay. Okay, this is the one set. We finished just one set, and then we can make it easily. Copy and paste. Paste. Okay, and we got 2. Accept long edit. Let's edit. Okay. Yes.
Let me go back, Control Z.
Okay, that's I think we need to change this one. So this one is number 1. Edit. Yes. Number 2 is this one. So we can modify this one. This one just number 1, and this one have to be. We have used the register timer register 1 and 0 and 1. Now it's 2. Enter. And this one is forward stop on delay timer. And this is on delay on timer of forward stop. And this is gonna be the same. And then this one, now this is 2. It's the same. Forward stop on delay timer output. Okay, this one on timer forward stop out. Okay, now it's done. And then this one also already used up there, so T4. Now this time is 3. This is saying forward stop off delay timer. Okay, and then this one symbol on time, off timer, forward, stop, out, 0.01, 10 seconds, same. Okay, then this one have to be number 3. Sorry, this one 3, and same thing. This one is mistake. This one, okay, not out. Okay, and then now we finished this one about sensor number 1 and sensor number 2. Okay, so basically if you have about 10 input, then you can assign 20 timers already, and then you only change this number, then everything done. So you don't need to worry about like adding new everything. You can standardize your program with the filtered output, and then I'm sorry, I didn't do this. This one have to be 1. It have to be different register. Okay, this one is filtered input of forward, stop, sensor, same thing. This one is filtered forward, stop, output, input. Okay, then we can see filtered. Okay, I just make it similar. Forward, this one filtered forward. Okay, now it's done. So test, yes, yep, and this one too. Accept long edit and test edit, yes. Oh, I did mistake. Test edit, yes. Assemble edit, yes. Now you can see 2 inputs. Probably you can make a copy. You basically you can make standard program. This one has 20 inputs. That means you make 20 inputs prepared, and then you only change this number, and then already everything is ready. So this is how you can standardize your program. Okay, then now we got input, and then I want to do the calling all the program here. Insert long. I'm going to call auto mode. Okay. I'm sorry. This one. This is a mistake. Same thing. JSR, jump subroutine. Jump subroutine is a little bit further. Okay. Jump subroutine, JSR. And then we need a number 3. 2 is already registered in the system. We start from 3. Okay, this one call auto mode subroutine. Okay, and additionally insert oops, insert. This is the same jump subroutine number 4 core subroutine of manual mode. Okay, and one more. Sorry, this where's that one? Program control, JSR. Okay, this one. Delete, and here insert long and JSR here number 6. This one core subroutine number 6 is output. Okay, and then accept long. This one we need many long already changed. Then you can just go offline, save it. Okay, and we can sorry, I did mistake. 1 second. Go online. Okay. This is my mistake. We better go this one. I finished this one first. Let's edit. Yes. Assemble it. Yes. And we 3 and 6. Okay. We go save it. And then we go offline. And then we edit. Insert long and insert long. Control C. Control V. Control V, and we only change this number to 3, and this one to 6. Okay, then we call subroutine auto manual input output, and then we accept this one, verify no, and then we all okay. Then we can download it. Then back to run mode. Then we edit all 4 routines. Now in the main program, I want to add one little thing to control the mode. Okay, this one long comment, edit comment. This is this program for starting of the mode change. Okay, and I add it. Okay, then I want to have a memory binary register B3 0 9 10. I need more. It's very small amount of memory, so I'm going to add more. What you can do, okay, let me this one, let me delete. Okay, and then we save it, and yes, we go offline, and if you go to memory, data files, then you can property, then you can see element. We got only one, so I want to add 50. Try and okay. Then you can see the difference. Now if I download it, then it will be heaps online, then heaps. You can use a lot. So now I want to use from 10 for the programming. The programming number 10 is this one symbol. Now this is auto mode memory, and this one is the auto mode memory. Okay, and this one manual mode memory. Manual mode memory register. Anyway, okay, this is auto and manual. So okay, in the program, as I can see here, insert long. Okay, this one edit comment. This one, this program control the auto manual mode. Okay, now we have button of input number, auto button, and this is a manual auto memory. Okay, and this one I can make a latch here. The auto memory. Okay, and then this one will be cut off by manual. Manual. Manual mode button. Then it will be latched by auto button and unlatched by manual button. So we can just accept wrong and test it. Yes. Assemble, edit, yes. And one more. Insert. Okay, this one will be the same. Copy, paste. Only difference, the structure is the same, but this one would be the 1, and this one also 1, and this one 5. The opposite, this one will be 4. That's it. So we can test it. Assemble, test the edits, and assemble edits, and this one delete. You can test it. If we press the button, auto, then auto memory, and manual will be manual memory. We'll keep doing this. Okay, this is the selection of auto and manual, and I'm going to do program of auto. Okay, insert long. Let's start from manual. Manual will be easier. Insert long. If it's manual mode, and the button pressed, forward button, forward button pressed, and reverse button not pressed, then you can just out. This is B. I want this one. We got last time we got 10 here. Now I want to this one 11. I want this one 11 area as a manual mode. So this one 11/0 is manual forward. Forward manual forward manual output. And this one manual reverse. This one manual reverse output. Okay, now this is the same thing. You copy and you paste it, but only thing you need to do, oh oops, this one B 3 11/0. Okay, and this one to B3 11/1. Okay, and this one common, this is same common, and this one to be 7, this one have to be 6. Okay, now we can accept long, test it, yes, assemble it, yes, assembly, and test edit, yes, assemble it, edit. Okay, now it's working. Now I can connect this one to output. In output, insert long, we need here B3 11/0 for forward. This one for forward to output, forward BC BC motor forward. But this is not enough, because we must have a minimum interlock here. This one have to be forward input, reverse, forward stop. You don't need to use filter input. You can use input directly. This is for the interlock. And copy and paste. And this is saying this one have to be reverse, have to be 1. This one have to be 0. Then this one have to be 1. Okay, then reverse, when it does reverse, then it will be stop. Okay, assemble it, test it, assemble it, set wrong edit, test edit. Okay, we can see here in the manual mode. Then now it's already manual. If I press the button, okay, I'll turn the camera on. I can show you. If I press the forward button, you can go further because this is interlock. And reverse is stop because the sensor is on. So we can't go further. Only can go reverse forward. Okay, this is how it works. We go back to program. Okay, now we finished the manual control. Now we going to auto mode programming. So we go auto. Insert long. The first thing we need to do, the condition auto memory is on, then we can this one is the same. I want to use this one as number 12, number 12, this one. Number 12, this is 11, number 12, and then this one auto forward output, and this one auto forward output. And this one auto reverse output, auto reverse output. Okay, that's good. And then this one have to be 1203, 12 and this one have to be auto memory, and this one when it auto, and also it should have a output. This one have to be when it forward, it have to be reverse stop. Sensor is on, then we can start go forward. That means, okay, this one here, I can put this on here and here, and this one same P3 12/0. Okay, then it will be activated like this, and also this one unlatched by the sensor forward stop, reverse sorry, filtered filtered forward stop. I think we had better use this one for filtered reverse stop. Yes. Okay, this is all, so we can just copy and paste. Then we can see we only change the number 1, this one to 0, this one to 1, this one to oops, this one to bit annoying. This one 2 1. Okay, then that's it. So we set up auto forward or auto reverse with the filter input. Okay, accept run, test edit, yes, assemble it, yes. Okay, now not in auto mode. I press auto mode. Okay, now it's on auto mode. So then this means this one now we can't start. It doesn't match. So this one of these have to be on like this. Then oh sorry, yeah, we haven't connected the output to actual DC motor output relay. So this one here. So manual, we have manual forward, manual reverse. This is the same. We need the oops. We need a reach, and we need a B3/12/0. Okay, then this one also same. This one here, manual. B3:12/0. Okay, then we can accept long, edit, test edit, and assemble it. Yes. Okay. Oh, sorry, I did mistake. I did delete that by mistake. Okay, B3:12/1. Okay, and we accept long edit, test edit, yes, assemble it, yes, let's start working. So again, if I stop it in the middle, like that, it's in the middle, even I'll go auto, in auto mode, so I put it in auto, not gonna work, because this have to be the sensor have to be see the conveyor, and then it can start working. So I bring the conveyor manually to the sensor, then it will start. Okay, if you want to stop, put it into manual. Okay, I'll show you the video camera. Okay. This is auto. Now it's in auto mode, but it can't start because this sensor have to be detect this part. Once it sees that, start moving. And if you want to stop, you put it manual, then you stop. In manual, you can operate manually forward and reverse. You can do by manually. Okay. We can do much more things. Yeah. But basic concept of this programming is the same. All the PLC program or any other things, any any other application with the PLC it has two major functions: auto mode and manual mode. These two you can call in the maybe one more like a control. This is control side of things, like a control mode control. This is mode control programming and mode control programming and auto programming, like this, manual programming and inputs and outputs. This is basic. So you start learning over any like a PLC or like a, if you analyze the program, then this is same. You can start from checking where is the auto program, where is the manual program, and tracking input to output. You're following input register, where is that connected to output, where is originally that output signal coming from. You change it up, then you can do troubleshooting. So this is all for today. Thank you for watching. Bye.